everyone for joining us for this live coding workshop. And first of all, let me introduce myself. I am Esteban Lopez. I am a senior machine learning engineer here at Factor. And like many people in data-related roles, I didn't study computer science or systems engineering or something specifically targeted for this kind of roles. I am a chemical engineer, and I did my master's degree and my PhD focused on dynamical systems. But due to my love of mathematics and my love of programming, I ended up in this amazing world. And I have 9 years of experience as a university lecturer and 2.5 years of experience as a machine learning engineer. So that's me. And very quickly, I'm going to go through a couple of slides to give an introduction of what we're going to do today. But then we're going to jump to live coding, okay? Because this is a live coding workshop. I want you to watch me create a FastAPI application from scratch to serve a machine learning model. So why this talk, let's say, or why this workshop? One of the most common first steps in making an ML model useful or making it ready for production, making or deploy it, is to create a service that can send the predictions of your model as responses to HTTP requests. HTTP being the protocol that we use the most to communicate over the internet. Most notably, we use it to get web pages and communicate with web pages, for example. And a common way to wrap a machine learning model into a service that responds to HTTP requests is wrapping it into a application programming interface. In this case, a web application programming interface, a web API that will allow us to interact with that service and send requests and get predictions in return. So enters FastAPI, a web framework that allows us to build APIs. And it was created by Colombian developer Sebastián Ramírez, also known as Tiangolo. And some of its features are that it runs code asynchronously, something that it has in common with other kinds of web frameworks that come from other languages, for example, from JavaScript. It uses Pydantic to validate requests and responses. Pydantic is a Python library that helps you validate models that are similar to data classes if you have any experience with data classes. But they are very strict in validating that everything that you define is the appropriate type. So FastAPI uses Pydantic to make sure that the request that the user sent and the response that the server returns have the appropriate data types in the let's say in the body of the request and response. And also, although this is of course more subjective, I think FastAPI has great documentation. It has documentation that reads like a book. And it is very interesting to go through the documentation and go step by step, getting to know the features of FastAPI. So a good read of the documentation is something that I think you should do if you are interested in using FastAPI to deploy machine learning models. We are not going to get to the deployment phase in this talk. We're going to focus on just let's say wrapping the model in a FastAPI that we're going to run locally. But remember, this is a common first step in the deployment process. You may know Flask, which is another web framework similar to FastAPI. FastAPI has positioned itself as a more modern alternative to something like Flask, and FastAPI has been around for like 4 or 5 years now, I think. And in this live coding workshop, what we're going to do is we're going to take a machine learning model that predicts the species of some penguins. We are not focusing on the model. We are focusing on serving with an API, right? So we will not spend time in the modeling part. The model is given. I'm going to go over it in a very brief manner in a moment. But we have a model that allows us to classify penguins between or among 3 species: Chinstrap, Gentoo, and Adderley, given some measurements of the beaks and the flippers of the penguins. In particular, we want our API to have 3 endpoints. Get endpoint to return the prediction for the features given as query parameters. I'm going to get into what query parameters are in a moment if you don't know. A post endpoint that returns the prediction given a JSON payload that we send to the backend, and a post endpoint to return predictions for multiple examples that we send as a CSV file. If you don't know what get and post endpoints are in an API, I invite you to look it up. But the gist of it is that get endpoints usually allows us to get information without having sent any payload, any big chunk of information to the backend first. And post endpoints are mainly for us, the users, to send information to the server so that the server can save it. That's the purest way to look at it. But in machine learning, post endpoints are very commonly used to get predictions, because sometimes you have many features, and it is very useful to have a payload to send with the features in order to get a prediction. So while the purest way of looking at endpoints would say that a post endpoint is not appropriate for this use, it is very commonly used so in machine learning. And that is my last content slide. Now I want us to get to the coding part of this live coding workshop. So I'm going to show you how I create a FastAPI application from scratch to serve this model. So allow me to open the folder where I want to do this with Visual Studio Code, which is where I'm going to use to write my application. Okay. There we go. So let's talk very briefly about the model. Remember, the model is already given, and it is not the focus of this particular talk. But we want to classify penguins. We have here a Jupyter notebook where I trained the model. I got this data from OpenML, and this data actually this has more columns, but I extracted only these 3 columns. The culmen length, the culmen is the upper edge of the beak of the penguin, the culmen depth, and the flipper length. Those are the three features that we are going to use to predict whether a penguin is from the species Gentoo, Chinstrap, or Adderley. And we have the label here, which is the species, of course. Then with those data, I just trained a simple random forest classifier after a hyperparameter search, and I got an accuracy of over 99% in the training set, and an accuracy of over 98% in the test set. And it looks like it is not showing my, somehow it is not showing my, here we have my confusion matrix. If you take a look at the confusion matrix for the test set, we are only making a mistake for 1 example. So this is a rather good model, and it is easy to see that it was going to be good, because just the culmen length and the flipper length allow us to separate these classes very well, right? Maybe there is some confusion with other pairs of classes, but these 2 at least allow us to get a good separation of classes. So a random forest will do a great job of a simple classification like this, right? And we have that model, and I have exported that in DIL format. DIL is similar to Pickle, but it has just some extra functionalities. So I basically pickled this model so that we get a file with a scikit-learn object that allows us to make predictions. That is the gist of the model. Now let's use that model, and let's wrap it into an API that can give us predictions when we send HTTP requests to it. So I'm going to take this model.deal file that I got from as the saved version of our scikit-learn object. And I'm going to paste it here in the root folder because I'm going to write my API code here in the root folder. I'm going to create a new file that I'm going to call main.py. This is going to be the main file of the API. This is a common practice. And here we are going to write the FastAPI code that allows us to have a service running. We will see it running locally, but I will also send you a deployed version just for you to play with it if you want to. And I will, in the end, I will send you a link to a repository where I have this code, or at least some version of this code that has been written beforehand and that is better documented. And that repository also has instructions on how to deploy it in AWS using ECS and Docker. But that part is outside of the scope of this specific tag. So let's get our hands dirty. That's right. Okay, I heard something about a transcription. I hope that's over. So let's import from FastAPI. And for this, you would have to have installed FastAPI, UVcorn, which we will use in a moment, and also sorry, I heard some. I think that something is trying to speak what we have in the. I think I have my voiceover in my Mac active, so I'm hearing something when people write in the chat. I'm sorry, so it's throwing me off a little. But from here we import the FastAPI class, which is the main class that we use to define our application. And we are going to define an application with that FastAPI class. So this is the application that we are going to create. And we want to add some endpoints to it, 3 endpoints in particular, the ones I mentioned before. And the way we add endpoints to this application is we decorate some functions with this kind of decorator. A decorator that is the get method of the app object that represents our API. Get in this case because we are creating a get endpoint. So we're going to create that first endpoint that I mentioned, which is that allows us to use query parameters. I forgot to tell you what query parameters are, and here we have them. Many of you have probably seen this a URL like this, where we have the base domain, a path to an endpoint, and a question mark, which marks the beginning of the query string, and some values, some keys and values there. One key equals to one value, the ampersand, and the other keys and the other values. You can pass several of them as query strings or query parameters. So these are the query parameters. And a get endpoint allows you to get information, and if you need to specify what information to get to the server, you do it with query parameters like this. We're going to create an endpoint that works like this. So we're going to have a get endpoint that's going to live at the home path of our application, and we are going to specify a response model, because we want the response of the endpoint to be a specific thing, and we are going to specify the format or the schema of that response next. So for that, as I mentioned, FastAPI uses Pydantic. So from Pydantic, I'm going to import the base model class, and when I do that, I can define classes like this. I'm going to create a class Penguin, which inherits from the base model, and we specify the fields that model or that schema is going to have as class attributes. So we have three features that characterize Penguin for us: the Kalman length, and we specify its type. It is a float. FastAPI will use Pydantic to make sure that it is a float every time we get a request and we send a response. We have the Kalman depth, which is also a float. And we have sorry about that. And we have the flipper length, which is also float. So this is the model that represents a Penguin for us. Notice it is very similar to a data class if you have ever worked with them. But that's what the information that we want. This is similar to information that we want to get, information about the features of a Penguin. But what about the information that we want to return? We can define another model for that. I'm going to call it the Penguin species prediction model. It also inherits from the base model, and it's going to have two keys or two fields. The first is going to be the features, and the features is going to be just another model that follows the Penguin model. So here we are basically specifying some JSON objects, how some JSON objects, what the schema of some JSON documents should be. And here we're saying, okay, the features key is going to have another whole JSON object that is going to have these other three keys. And besides of that, is going to have the prediction, which is going to be a string telling us if the Penguin is a Gen 2 or a Chinstrap or an Adelie. So these are the models that we are going to use, and we can specify that for our get endpoint that we're going to write first, the response model is going to be the Penguin species prediction. We want our get endpoint to return something or a JSON document that conforms to this model, and we tell that to FastAPI here. So with this decorator, we decorate a function that we can name however we like, but a descriptive name will be better, right? So I'm going to say get prediction from query parameters. And the arguments that I specify here for this function are going to be the query parameters that we are going to require. So I'm going to use CL for Kalman length. It is a float. CD for Kalman depth, which is also a float. And FL for flipper length, which is also a float. When we pass these arguments, we are telling FastAPI that we want these query parameters that they have to be interpreted as these data types. And FastAPI is going to use Pydantic to make sure that they get interpreted as floats. And then we just return our prediction conforming to this model. So we could get, something I forgot to do here was defining a constant, which allows us to map indices to category names. So I want to specify that 0 is the Adelie class, that 1 is the Chinstrap class, and that 2 is the Gen 2 class. There we have that information as a dictionary there. And we will use it because scikit-learn will give us a 0, a 1, or a 2, right? We will use the dictionary to turn that into an Adelie, Chinstrap, or Gen 2 string to format the prediction in a way that is human readable. So we will get the prediction using our model, which is another thing I haven't done in the, let's say, in the first part here of my script. I have to load the model. So with open model.deal, in the read bytes mode as open, I'm going to import the deal library and I'm going to use it to define a model object by loading the contents of that file. Remember, this file comes from the Jupyter notebook where we trained our random forest. There we go. So here we have access to our model. And we have access to the predict method of our model. Remember, this is a scikit-learn object. And we can run prediction on a single sample of CL, CD, and FL. This, I'm using the correct order here for the features. The scikit-learn model is expecting first the Kalman length, then the Kalman depth, and then the flipper length. So this gets us a number 0, 1, or 2 with the predicted class, and we can turn it into a string just by mapping it through this dictionary, right? So here we have the prediction as a string. The next thing that we have to do is return something that conforms to the penguin species prediction model. And we can just return a dictionary, and FastAPI will know that it has to parse that dictionary according to this model, and it will parse all the data types appropriately, and it will raise the appropriate error if we did something wrong with the wrong data type. So it is a nice feature of FastAPI. So what we have to get here is one key is features, and it contains a whole new document or dictionary with the features that characterize our penguins. So I'm going to make these strings here. I'm going to specify that the value of the Kalman length is CL, the value of the Kalman depth is CD, and the value of the flipper length is FL. And I'm going to write these commas that I had missed here. And then we also need to get the prediction key into this dictionary, and the prediction is just going to be pred. The string, either Adelaide, Chinstrup, or Gen2, Adelaide, Chinstrap, and Gen2 that we got from the prediction of our model. And this is the endpoint. This little function here is the endpoint that uses our model to get the predictions. Let's try to run it to see how it looks. So let's add the usual here to make this a script that we can run. And when we run this as a script, what we want to do is we want to import Uvicorn. Uvicorn is an asynchronous web server that can run FastAPI applications. So we will use Uvicorn to run our FastAPI application. We can do it with uvicorn.run. And what we pass here is the name of the file where the application resides, main, without the extension, a colon, and then the name of the variable that is our FastAPI object. That would be the app object here. And then we could specify some other things. For example, the host where this is going to run. For this example, it could run on local host, so it will be running on our local machine. The port where it will run, I'm going to use port 8000 here. And in this case, in particular for development, I'm going to specify reload equals true. That means that every time Uvicorn detects a change in the source code of the FastAPI application, it is going to reload the application. That means that our changes are going to get, let's say, deployed to our local deployment every time we save the new version of this file. So let's try to run this script here, and it should start a Uvicorn server. It is running here at localhost colon 8000, and we can go there to see what's happening there. There is a a warning here about the version of scikit-learn that I am using, because I am using quite different versions. I use a very different version to train the model from the one that I'm using to run inference. Well, the warning is good to pay attention to. It is not a problem in this case. So I'm going to go back to my browser, and I'm going to go to localhost, in this case, localhost 8000. If I go there to the home of this URL, I'm going to see this error message telling me you haven't specified the column length, you haven't specified the column depth, and you haven't specified the flipper length, because, well, I certainly haven't specified them. And Pydantic tells me you have to specify them because you made them requested parameters of your endpoint, and I can't specify them. I can write a question mark here and specify that the column length is let's say 50, and the column depth is let's say 12, and the flipper length is 200, and we should get a prediction. But we didn't, because I am missing an equal sign here, so it didn't recognize the CL. Okay, something that I forgot about here is that I had to pass this as a NumPy array. Oh no, actually I didn't have to do that. I forgot to extract the first element here, because I have to pass a batch of examples. I get a batch of predictions, and I only need the first and only one of them. So I was missing this, and once I save, our application is going to reload automatically because of this little option here. So if we go back and we send this time this works, and we get what we expected, a JSON document with the features, the same features that we specified, and the prediction. In this case, we are predicting that a penguin with these measurements is of species Gen 2. But this ugly way to get this is not the only way. We can get access to a user interface that is way nicer if we go to the docs endpoint, which gets us to some pre-formatted and automatically generated FastAPI documentation using the OpenAPI specifications. So here we can test our get endpoint. If we click here, try it out, we can specify the features in this more comfortable way. Let's see what happens when we try these other sets of features. And in this case, we get Adelie as the predicted species for the penguin. So that's the get endpoint. And let's say if you know front end, or if you have front end engineers working on your application, you can make the front end engineers, or you could also do it yourself, send a request to this endpoint, to this address, to this URL, and get the predictions back. So this, by the way, is the documentation telling you if you want to use this endpoint in your terminal, in a Unix terminals, in your Mac or Linux or something like that, you can send the request in this way using the curl command, and you will get the corresponding response. So that is the first endpoint that we wanted to create. Let's create some more, and it will be easier now that we have started. So let's create a post endpoint that will live at the /JSON path, and it will have the same response model, but instead of using query parameters, because FastAPI interprets arguments directly passed to the function as query parameters, we will say that we are expecting a penguin model, and that will change things. Let's see. So get predictions or prediction from JSON. I'm going to name this function like this. And instead of specifying the column length, the column depth, and the flipper length separately, I'm going to specify the following. Just get me a penguin here. And since this is a pedantic model, FastAPI is going to know that what I'm asking for is a JSON. So this is a post endpoint that is expecting a JSON payload. It is expecting the user to send the features as a JSON, and it will return also a JSON with this other model with the prediction. So we can do something very similar, but instead of having the features as CLCDFL, we have the features here as penguin dot column length, penguin dot column depth, and penguin dot flipper length. And we can make this nicer, better formatted like this. And then again, we get a prediction and we pass it through the dictionary to get, instead of a number, we get the string. And now we return a dictionary, but instead of specifying this manually here, we can just say that the features key is going to be the same penguin we received, because remember, here we are just specifying the same features that we received. They are the same features that we received here, and we can specify that we deliver them again here. And in addition to that, prediction key, which will be this object pred. And if I save this, notice that my first of all, we have a mistake here, a syntax error, because I hadn't added dot column. But when I save, this gets reloaded, the application gets reloaded. And if I go to my browser and reload, you will see that now I have 2 endpoints instead of 1. Besides the get endpoint that we defined first, now I also have the post endpoint that we just created. And we can try it out. We can say, okay, notice this time we are not sending the information as query parameters. We are sending a request body, a payload, so with some information, and that payload will be a JSON document that we send. A JSON document specifying the column length, column depth, and flipper length according to the model for that penguin class that we define here, which we require FastAPI to we requested FastAPI to make that model the JSON that it asks for by default when we specified here that this has this type. So we can specify something like 45 millimeters of column length, let's say 15 millimeters of column depth, and 170 millimeters of flipper length, and let's see what we get. And this time we get agent 2 again. So notice we get the same JSON with the same model, following the same model as with the get endpoint. It has a features key, which has all the features, and a prediction key with the predicted class. But we sent the features as another JSON instead of query parameters. That's useful if you have many features. If you have hundreds of features, you probably don't want to be writing them all in this as query parameters in this manner. That would be quite ugly, really. But if you have hundreds of features, it is way better just to send a payload, JSON, with the features in the keys of that JSON, and it will be much better if you have many parameters. So that's our post endpoint that gets a JSON and returns a JSON. And here you also have how to send that request with a curl command in your Unix shell. You can set a post request to this URL with some appropriate headers and with this data. With this data is just the JSON payload that we sent. 45, 15, 170 for the features. And Pydantic, notice that Pydantic received this as integers, and it turned it actually turns it into floats. Not here, because here we just pass the same thing we get, but it formats them correctly as floats, so, because we specify in the FastAPI or FastAPI application that they should be floats. Even if we try to make one of them a string, I think this should still work. And even though we send a string, it still gets interpreted as a float by FastAPI and Pydantic, and that validation saves the date there, because otherwise this would be an error. That's the post endpoint. Now let's write our third and last endpoint that we want to write, which makes us create an endpoint to handle files. That is very interesting. So we'll create another post endpoint here. This one is going to live at the /file, at the /file path, and instead of specifying a response model, we specify a response model when we want to specify a JSON, the schema of a JSON for the reply. But in here, we want to get to give a CSV file to the backend, and we want to get a CSV file with predictions in return. So instead of a response model, what we could specify here is a response class. And we are going to import from FastAPI .responses. I'm going to import a streaming response, which is the kind of response that we can use to respond with files. I also have to import the file function here in order to tell the FastAPI endpoint that we will receive a file. So this is to tell the app that we receive a file. This is to tell the app that we should send a file in return. So as the response class, we specify a streaming response. And let's call this function get predictions from file. I just heard that there was a question there, but we'll leave questions for the end. Sorry about that. So get predictions from file will be the function that we'll define for this endpoint. And what we will ask here is a file. And we specify that by saying it is of bytes type. And we will specify to FastAPI that it is a file in particular, like this. We are just saying here that it should be a file. FastAPI should get a file, and it should interpret it as bytes. And these three dots here, this ellipsis, just means that that file is a required field. You won't get predictions if you don't upload a file. That's important. Okay, so I'm going to try to process this file, and for that I'm going to get the file contents as a string. And the way to do that is just to decode the file, because remember, it will be a bytes object, but it represents a string really. If we decode that, it will be a string. Of course, we could specify that we decode using the UTF-8 encoding, which is the most common, and it will work. And those will be the contents of the file as a string. And we are expecting the file to be just a CSV without headers. sorry, every time someone writes in the chat, I get the voiceover, so it distracts me. So we are going to split that file by row, because we expect it to be a CSV without headers. We will not trouble ourselves with headers right now. It will have the columns of the features in the order we need them: column and length, column and depth, and flipper length. And we'll split that into lines. So if we apply this method, let's create this variable here. If we apply the split method, it will automatically split by empty space or white space. So it's going to give us the lines. And then each line, for us to get the features, let's say, or the example, the x's, the x's that we are going to use to predict, we should split every line by the commas, right? Because this is going to be a CSV file, comma separated values. So we're going to split by the commas to get each feature separately. So we're going to say that for each line in input lines, we are going to have, and I'm going to import NumPy here to be able to turn this into a NumPy array. A NumPy array of what we get if we take those lines and split them by the comma. A NumPy array with a data type of float, by the way. Line, that should be line. So this is going to get our x's. We can get our predictions like this. If we just apply the model to that x's, we will get our predictions, but we will get them as a list of numbers, 0, 1, or 2, according to the classes. We want to get the strings. One easy way to do it without writing too many lines of code would be importing the following. From operator, I'm going to import the item getter. It is a nice tool of Python that lets us get multiple items from a dictionary at once. So I'm going to say that the predictions, this time as strings, not as integers, are going to be the following: the item getter, and we pass the previous predictions unpacked so that they are not passed as a list but as arguments. And we apply that to the cats dictionary. So this is basically getting all the values for all these keys from the cats dictionary. That will turn this, which was a list of integers, into this, which is a list of strings with the predictions. And now we want to reformat this to get a file for us to send to the user so that the user can download it. Let's do that. So we can get the output lines doing the following. For each input line and each prediction, let's call the prediction just P, in this iterator, input lines and pred. If you have used zip in Python, you probably know that this allows us to iterate over 2 iterators at once. So line will be iterating over the input lines and P over the predictions. We just need to do line plus a comma plus the prediction, and that will get us the features and the prediction as part of a new CSV file. That command doesn't go there. And then we join all those lines with new spaces, or sorry, with new lines, so that we get a properly formatted CSV file. So those output lines will be joined with new lines, and they will be parts of lines in a CSV file. Another step that we have to do here is that we have to convert this back to bytes, because right now output is a string that represents a CSV file. but since we want to send it as a file to our user, we want it back to bytes. And we can do that by specifying the following: output.encode. So this makes the string a bytes object. And now we have to return something. And what we return for FastAPI to actually return a file is a bit special. We have to use the streaming response class, and we have to specify the content. And the content is, in theory, a file, but we don't want it to be an actual file, because that would make us write the file to disk and then read from disk. That's extremely slow. It is much faster if we keep everything in memory. And if you have experience with Python, you know that an easy way to simulate a file, but actually having all the data in memory instead of disk, is using the bytes IO object. So from IO, I'm going to import the bytes IO class. And if I say here that our contents are a bytes IO object with those bytes, this will simulate a file without having to write the actual file to disk. But this will simulate it, and that will help our code be faster, because writing or reading from disk is way slower than doing things in memory. But we also have to specify a couple of things. The media type is important in this case. The media type tells the browser the type of file and the extension of the file. So it's a text file with the CSV extension. And in this case, we also have to specify some headers. Headers are just some configurations that travel with requests and responses in the HTTP protocol, with some important information about those requests and responses. In this case, we need to specify a content disposition header that tells the browser which kind of content we are sending, and since it is a file, what is the name of that file. So what we say here is that this is an attachment. That way the browser knows it will be something to download. Semicolon and a file name. This way the browser knows what the name of the file should be when it downloads it. And I think that's it. That's all we need to get our post endpoint that handles files going.
So sorry, Esteban, to interrupt you. We are running out of time, so maybe if you can demonstrate that, and we will go quickly over the Q&A, and then we can finish the talk. So
sure, thank you, Pablo. We're about to finish here. So I'm going to I reloaded the application by saving the file, and I'm going to go back to my browser, reload the page, and here we have the new endpoint. We're going to try it out. And to try it out, I'm going to need to send a file to it. And I have here, okay, I'm going to need to go to my desktop, and here, along with the ML model, I also have a test sample. And the test sample is just, I will show you what it is. The test sample is just this CSV file with some values for each feature. So if we upload that file and execute the endpoint, we're going to get another file in return. And if we click here, download the file, my browser actually downloads the file. It downloads it with this one here because I had previously tested this. So I have a file with the same name in my downloads folder. But if I open it with Visual Studio Code, you see that it is just the same features, but with the addition of the predictions. So we return another file that has the features and, in addition, the prediction for each Penguin. That will be all the content I have for you, but I want to send you a couple of things before I finish, because I want to send you the link to this repo, which has this code and some other stuff about deployment. You could find it useful. So I'm going to send this to the chat. And
right
I'm going to
Excel.
I am going to send this in case this is a small deployment of this application in case you want to play with it. And we can start the Q&A now. I'm sorry I took a bit longer.
Yeah. Okay. Let's go quickly through the Q&A. So, what alternatives do you recommend for managing the errors? And specifically, I think they refer to the error you got when you pass an NP array. Do you have like any recommendations in mind?
Well, in that case, the best suggestion is having tests. Actually, the repo that I sent you has a test. I didn't have time to implement the test here, but it has an example of a test, a unit test that makes sure that your application, or more of a functional test that makes sure that your application runs correctly. Having tests allow you to catch those errors before you get to production.
Yeah. Could you explain in which case we should use post or put methods?
Put is most commonly used to modify a record in the database of something that already existed. That's the main use of the put method if we're purists. And post is when we want to use that information so that the server creates a new record in the database that didn't exist before. That's the main distinction between put and post.
Yeah. What should we change when we have another format, such as .parquet? Does that work as well?
If we have another format, you will have different tools. If you have Parquet, you will need something like PyArrow, I guess, in order to read the file in your endpoint. And if you need to return a Parquet file, you would have to specify that in the content disposition and in the media type. In the media type, you will probably say like binary/Parquet, because that's a binary file, and the content disposition, the appropriate name for the file. And that would be basically the changes.
Okay. Sorry, we ran out of time, so we have to end there. But thanks for attending. Goodbye.
Thank you, everyone. Bye-bye.